Hello, this is your review for Unit 4. So number 1, we have a function that is increasing, so going up, and concave down. So it's going to look something like this. And we want to put the Riemann sums in order smallest to largest. So if you put your L and your R in there, the left sum is going to be the smallest, trapezoidal is going to be somewhere in between, and the right is going to be the biggest. It's going to be a multiple choice question. Which of the following is the smallest, or which of the following is the biggest, given a function that is doing these things? All right, write a definite integral. So we just need to figure out where we are starting and ending and what our function is. So all of this is going to represent x. We're going to have 3x squared dx. And then our starting number is going to be 1. And our change is 7. So 1 plus 7 gives us 8. So that 7 is your delta x. That's the length of your interval. And 1 is where you're starting. All right, for this one, we're going to find a right Riemann sum. We are going to have to actually work this the whole way out. You can't just leave it alone because it's going to be multiple choice. And they won't just leave that as their answer. You have to actually, calculate what it's going to be. So length of the first subinterval is 2. It is a right Riemann sum, so our number on the right is -3. And then we're just going to keep doing that. From 3 to 4 is 1. Number on the right is 1. From 4 to 6 is 2. Number on the right is 5. And from 6 to 10 is 4. Number on the right is 4. Again, free response. You know what? I don't like how this light is looking. Let's see if that's, hopefully that's better. On free response, you can just stop there and leave it like that. You don't have to actually work it out. But for multiple choice, the choices aren't going to look like that. So you're going to have to actually figure out what this equals. So let's see, 10 and 6 would be 26. Minus 6 would be 20, plus 1 would be 21. So however your brain does that, you do need to actually get an answer to pick A, B, C, or D. All right, here we want to find the integral from 0 to 5. That means the area under the graph from 0 to 5. So that's this area, which is going to be positive, and then this area, which is going to be negative. So our first shape is a rectangle, and I printed this from my printer at home, which means it printed very faintly. I think that's 3 by 2. And then this is going to be negative. It's a trapezoid, so 1/2, and then the height, which the trapezoid is on its side. So this is the height, which is 2 units. And then it's base 1 plus base 2. So this appears to be 2, and this appears to be 4. Again, you'll be able to see it really well on your test. I used my home printer for this, and it just didn't print very well. So hopefully that's all correct. 6 minus the 1/2 and the 2 are going to cancel. 6. So it actually ends up being 0. The area above the x-axis and the area below the x-axis are equal. So ended up being 0, interestingly enough. All right, use the graph to find the value of integral 0 to 8. So we want to find the area under the graph from 0 to 8, which is this right here. So what we're going to have to do is find the area of this rectangle and then subtract this semicircle out. So we're going to do the whole rectangle and then subtract this negative space. So our rectangle is 8 by 5. And then we're going to subtract 1/2 pi r squared. And that radius is 4. So let's see, that'll be 40 minus 8 pi. Right, evaluate an antiderivative. This is an indefinite integral. There are not boundaries, so I do need to put a plus c. I'm going to just off to the side write this with the negative exponent. I didn't actually do the problem yet, which is why I kept my integral symbol and my dx. Once I do the antiderivative, I don't have to write those symbols anymore, and then I'll put the plus c. So we want to add 1 to the power. It's going to become -3. And so in front, I want to put a -1/3. Sometimes the answer choice might look like that. If they fix the negative exponent, it will look like this. So either one of those is the correct answer, whichever multiple choice looks like that. All right, for this one, we have, again, indefinite integral. We have 4 secant tangent. So you need to come up with a trig function that has a derivative that is secant tangent, kind of like that's the answer. You want the question. The derivative of secant is secant tangent. So going backwards, antiderivative, we get 4 secant x plus, and then that would be 5x and then plus c. Right, this one is a definite integral, so we're going to find the actual numeric answer for the area under the curve. So antiderivative is going to be 2x cubed plus 2x squared, such that -1 to 2. So once you do the antiderivative, you don't write the integral symbol in the dx anymore. You're going to instead put this such that at the end, and it's going to be upper boundary minus lower boundary. So plugging in 2 cubed is 8 times 2 is 16. 2 squared is 4 times 2 is 8. And then plugging in -1, we're going to get -2 plus 2. You can't stop there for multiple choice. Free response, you totally can stop there, and that's what I want you to do, because if you keep going and you mess it up, then it's going to be wrong. But none of your choices A, B, C, and D are not going to look like this. So you have to keep going. These are going to cancel, and so 16 plus 8 is 24. So this is how this looks with U substitution when it's multiple choice. They're going to give you U equals this, and you don't have to actually work the problem the whole way out. They just want you to rewrite it. So they kind of got it started for us. This is going to be 3dx. We're going to adjust it with a 1/3. So 1/3 is going to go out front. Du goes at the end. And inside of there, we're going to have u squared. And then you have to adjust your boundaries. They are forcing you to do it. Can I just not adjust them? No, they're going to make you do it. So you have to plug in 0 for x. That's going to give you -1. And then you have to plug in 5 for x, which is going to give you 14. And then that's the answer. That's the kind of good thing about it, is you don't have to actually go any further. They're just asking you to do the substitution. All right, here we're going to have to actually go the whole way. We're going to do an entire u substitution. U is going to equal the inside part, the x squared plus 7. Du would be 2x dx. I'm going to adjust it with a 1/2. So in place of the x and the dx, we're going to put 1/2 du. So 1/2 goes out front, du goes at the end. What's still there is u to the 4th. Don't forget to actually do your antiderivative. It'll be 1/5 u to the 5th plus c, because I don't have boundaries here. It's indefinite. And then I'm going to plug back in for u and also fix those fractions out front. So it'll be 1/10. X squared plus 7 to the 5th plus c. For this one, I need to complete the square. So off to the side, margin problem, I'm going to write my x squared plus 8x. You divide by 2 and square. So 8 divided by 2 is 4, squared is 16. I'm going to give that a hug. And 16 plus 9 gives me 25. They're both going to be perfect squares, if that helps at all. Also, I'm going to take the 8, put it out front. It's going to be 1 over something squared plus 9, and then my dx at the end. So looking at this, if you factor it, it's going to be x plus 4 times x plus 4, so x plus 4 squared. A is going to be a number. U is going to be a variable. So A is 3. 3 squared is 9. U is the x plus 4. For good measure, du is just dx. And this is your arctangent. So you're going to have 8 and then times 1 over a. And so in multiple choice, it's going to look like 8/3. And then arctangent of x plus 4 over 3 plus c. And then that is your answer. I'm going to box that in because it kind of ran into my margin problem that I did here. But you just need to be able to identify the answer, because you're going to have choices to look at. That would be multiple choice. For this one, -2 goes in the little box off to the side. We're going to do our synthetic division. Stealing the coefficients from this would be 169 bring down the 1. We're going to multiply, add until we get to the end. So that would be -2, add the column, you get 4, -8, add the column, you get 1. So our integral 2 to 4 is going to be 1x plus 4, and then our remainder is 1. So it's going to stay over the x plus 2. Basically, we're saying we were unable to divide that part out. And now we're going to do our calculus. We didn't do any calculus yet. This is just division. Antiderivative, 1/2 x squared plus 4x, and then this is going to be an ln. Oops, can't write. Ln of x plus 2 such that 2 to 4. We're going to do upper boundary minus lower boundary. So plugging in 4. 4 squared is 16. Half of that is 8. Plus 4 times 4 is 16. And then plus ln 6. Plugging in 2. 2 squared is 4. Half of that is 2. Plus 2 times 4 is 8. Plus that would be ln 4. You have to keep going because it's going to be multiple choice. None of the choices are going to look like that. They're going to simplify it down. So this will be 24 plus ln 6 minus 8 and 2 makes 10. And then distributing the negative, it'll be minus ln 4. So final answer, 24 minus 10 is 14. And what they are going to do with the natural logs is use properties. When you add, you multiply what's inside the log. When you subtract, you divide. So since we are subtracting, we're going to divide 6 and 4. And actually, that would reduce to 3/2. So your answer would look like this. So again, multiplying or adding, you would multiply. Since we are subtracting, we divided. 6 divided by 4, and the fraction just reduces. This looks like a whole lot. Let's unpackage this. Integral 0 to 8 for f of x is 9. Integral 0 to 8 for 1/3 g of x is 2. The very first thing you would do is want to multiply that 3 to the other side. So let me go ahead and rewrite this so that it's just g of x in there. 2 times 3 is 6. Because I know I'm going to need to do that. I don't want that 1/3 in there. All right, and then 5 to 8 for f of x plus g of x dx is 1. And then 0 to 5 for f of x plus g of x dx is the thing that we're supposed to be finding. This is going to be poor notation because I don't want to write all of this f of x plus g of x dx for every single one of these. But integral 0 to 5 of all of that plus integral 5 to 8 of all of that is going to equal integral 0 to 8. So it's like you're going from 0 to 8, but you did a rest stop at 5. Okay? So 0 to 5, f of x plus g of x dx is the thing you're looking for. I'm going to just call that x. Or any letter of the alphabet. You can call it whatever you want, but this is the thing that they said to find. That's the thing that's missing. Okay? From 5 to 8, f plus g, they said was 1. And then from 0 to 8, this is where the rest of this comes in. 0 to 8 for just f of x was 9. 0 to 8 for just g of x was 6. We need to add those together. So 9 plus 6 is 15. And if you solve for the thing that you're missing, you get 14. So it's using all of your properties. This one is fundamental theorem. We have a definite integral of f prime. If you go backwards, if you do an antiderivative of f prime, you just get f of x, and then such that -3 to 0. So it's going to be f of 0 minus f of -3. We're going to do upper minus lower, and then use our table. You don't need anything from this part of the table. That is extra information that is there to confuse you. All right. F of 0 is 6. F of -3 is 2. And so your answer is 4. Get the correct paper here. All right. Now we're on to the free response. Sand is pouring through an hourglass. The amount of sand is given by differentiable function, S, time is in seconds. So we have grams of sand and we have seconds. Is there a time from 1 to 3 when the derivative is a half? Justify your answer. So we want to go from 1 to 3. Don't be too proud to write out your points. We want 1, 0.4, 3, 1.4, and derivative means slope, so I want to find a slope. So this is going to give me 1/2. Oh my gosh, that's what it came out to. So the theorem that this is mean value theorem. Your average rate of change, which is your slope, is going to equal your instantaneous rate of change, which is your derivative. So we're going to say, this is where your sentence comes in. It's kind of like essay writing. Since S is differentiable, it is continuous. And I will take diff and con. Please, on your AP exam, write the whole word out. I don't know if they'll take those, and it's just not worth it. But I'm fine if you abbreviate. So since all this is true and we found this slope, basically we're just going to repeat the prompt. There is a time from 1 to 3 when the derivative equals 1/2 by mean value theorem. All right, approximate 1/6 integral 0 to 6 with a midpoint sum. So that 1/6 is kind of just there. They just stuck that in the problem. We're going to do a midpoint sum. So I want these to be my subintervals so that I can get a midpoint. So there's only going to be 3 of them. I can write this in the abbreviated way because each subinterval is 2 units in length. This one's 0 to 2, 2 to 4, 4 to 6. So I'm going to take 2 and add together all of my midpoints. So 0.4 plus 1.4 plus 2.5. And unlike the multiple choice, you don't have to do anything to that. Please don't. Please leave it alone. So that is our approximation. Using correct units, explain what it means. Because there is a 1/6 out front, that makes it an average. Remember your average value, I'll just write this off to the side, 1 over b minus a, integral a to b, f of x dx. That fraction out front is what makes it an average value. So we're going to say it is the average amount of sand in grams, and I have to say that because it said using correct units. Average amount of sand in grams from, when was it? 0 to 6 seconds. So the grams and the seconds is your using correct units. Saying average is because of that 1/6. That's right there. All right, part C. The amount of sand for times bigger than 6 can be modeled by this awful thing. Using this model, find the rate at which the sand is changing at time 8. So what we're going to do is find the derivative and then plug in 8. It's non-calculator, so you can leave everything alone. Please don't overthink this because since it's E, it's actually a pretty easy question. 14 is a constant. When you do the derivative, that's going to be gone. E is itself. So it is simply going to be negative 12 e to the whatever, negative 0.2t. And then there is a chain rule. You have to chain on negative 0.2, negative 0.2. And then you're going to just repeat this and plug in 8 for your time. And that is literally it. They didn't ask for units. They wanted you to find a derivative and plug in 8. Just don't do a copy error. That is it. All right, these last two, 16 and 17, are the calculator allowed. This says, what is the average value of this function interval negative 1 to 1? So we're going to have 1 over 1 minus negative 1, integral negative 1 to 1 of this function dx. And I'm going to share my screen and just put that in the calculator. These would obviously cancel. It's going to be 1/2 that's out front. Oops. X squared plus 2x. I know this is super fun to just watch your teacher type this in. Dx. All right, and then there's your answer. You need 3 decimal points, 0.517. Right, and then last one, again, calculator allowed. This is your last free response one. Approximate the rate. Oh, let me read first. Water is draining out of a tub according to the values in the table. So since the water is getting less and less, see how the numbers are going down? The water is draining out. So the amount of liters is going down as time goes on. Approximate the rate at which the amount of water is changing at time 0.5. 0.5 would be in between here. We're going to do a slope. Again, do not be too proud to write out your points. It helps that you can see them. So 40 minus 45 over 1 minus 0. It would be liters per minute. Don't do anything to that. It's free response. All right, this one is exactly the same as what is on the other side. Yes, I put 2 of the same question on the test. See that 1/7? It makes it an average value. Only difference is instead of midpoint, it's trapezoidal. So I'm just testing you on finding a different sum. So we're going to have 1/7 and then do a trapezoidal sum and then explain what it means. It's going to be the exact same explanation that we did on the other side of the paper. I cannot write this in the abbreviated way because all of these sub-intervals are different lengths. So buckle up, here we go. 1/2, you just have that because it's part of the trapezoidal formula. Length of the sub-interval, 0 to 1 is 1. Add the bases together, 45 plus 40. And then do it again, 1/2, 1 to 4 would be 3, and then 40 plus 30. And then again, 1/2, 4 to 5 would be 1, 30 plus 22. And then last one, from 5 to 7 would be 2, and then 22, oops, 220. Why on earth did I write that? 22 plus 15. Please don't try and simplify that down. I get that you're allowed a calculator, but why? Like, it's a timed test. Do not try and put that in the calculator. Like, just leave it alone. All right, using correct units, explain what it means. It is the average amount of water in liters from, when was it? 0 to 7 minutes. So again, your minutes and your liters are your units there. Average is because it says 1/7. And I guess you could even go so far as to say average amount of water that drains out in liters from 0 to 7 minutes. I mean, as long as all your units are there, you're good. All right, this is fundamental theorem of calculus. We have an integral and then L prime. If you go backwards and do an antiderivative of L prime, you are going to just get L such that 0 to 7. We want L of 7 minus L of 0. And I'm going to come up here and find those. L of 7 is 15 minus L of 0 is 45. So that is going to be -30. And then they want an explanation of what that means. Well, if you subtract the amount you have at 7 minus the amount you started with, these are just amounts. This is just amounts in liters. If we take the 15 that we ended up with minus the 45 we started with, it means that 30 liters drained out from 0 to 7 minutes. Means your amount decreased by 30 liters from 0 to 7 minutes. And then the last one, okay, there's a second tank that is also draining. The amount in this tank was originally 62, so that's what we're starting with. And the derivative, so this is the rate, is given by that awful thing. We're allowed a calculator. This is where the calculator comes in. At time 7, what is the difference in the amounts of water of the 2 tanks? So let's do tank number 1 and tank number 2. At time 7, tank number 1 has 15 liters. It's just handed to us right there. At time 7, tank 1, 15 liters. Tank 2, we're going to have to use this information. Starts with 62, not 61. And then we're going to have to do our integral from 0 to 7 of this a prime of t. When I type it in the calculator, I have to type this awful thing. But when you go to write it, just write a prime of t. Number 1, it's faster. And number 2, if you copy any of this wrong, it's going to be wrong. Okay, so let me go and put that in the calculator. So it started out with 62 liters, and then we drained from 0 to 7 according to, and you can see that it's draining because it has that negative in there. 0.486 e to the power negative dt. All right, 11.786. We can truncate. 11.786. You can see down in the corner where I wrote that. Now, that's not the final answer to the question, though, because it said, what is the difference in the amount? So I'm going to take that 11.786 and subtract, I'm going to just keep typing here, the 15 that was in the other tank. So the difference between the tanks is 3.213 liters. All right, I think it stopped showing. Okay, so I just subtracted these from each other in the calculator, and then this is the difference between the two amounts. That's the final answer to the question that it was asking.